So here in this question, in an N-type semiconductor, which of the following statement is true? And the options are: option number 1, electrons are minority carriers and pentavalent atoms are dopants. Option number 2, holes are minority carriers and pentavalent atoms are dopants. Option 3, holes are majority carriers and trivalent atoms are dopants. And option 4, electrons are majority carriers and trivalent atoms are dopants. Now, if you remember the formation of N-type of semiconductor, so when we are initially having a pure semiconductor like silicon or germanium, and we want to convert this pure semiconductor into N-type semiconductor, then we have to add an impurity which is pentavalent in nature. So if you add an impurity which is pentavalent in nature, then we will get N-type semiconductor. N-type semiconductor. Now, when we add a pentavalent impurity and when we get N-type semiconductor, in N-type semiconductor, the majority charge carriers will be electrons. The majority charge carriers will be electrons because we are adding a pentavalent impurity to a pure semiconductor. So, majority charge carriers are electrons and minority charge carriers are holes. So, holes will be minority charge carriers. Okay. So with this background, if you see these statements, so the first statement says that electrons are minority carriers, which is false. Second statement says that holes are minority charge carriers, which is true. And pentavalent atoms are dopants, that is also true. So out of these 4 options, the option number 2 is the correct answer. That is, in an N-type semiconductor, holes are minority carriers and pentavalent atoms are dopants. So here you can see option 2 is the right answer. Holes are minority charge carriers and pentavalent atoms are dopants.